In 2019, a man sold his side project for about $670 million. 6 months later, armed police raided his home and his office. The charge? That the code was never really his because he'd written it while employed somewhere else. He had written it after work, on his own time, as a hobby. And that hobby is, right now, quietly running about a third of every website you visited today. Welcome to Region 4. Last time we climbed down into the materials warehouse and worked out where your data sleeps at night. Tables, indexes, transactions, all of it humming away beautifully on your laptop. And that's the joke nobody warned you about. Everything we've built across 3 whole regions is currently locked inside one machine, in one room, that goes to sleep when you close the lid. Today we drag it outside. This is the road out into the world, and it's the longest, most booby-trapped road in the entire book. Let's start with the exact moment your heart breaks for the first time. You type your run command. The terminal prints localhost, :3000. You click it, and there it is, your site, beautiful, working. So you copy that address, send it to a friend, and wait for the applause. Your friend writes back. Doesn't open. And you stare at that message thinking, but it works. I'm literally looking at it right now. Here's what happened. Localhost is not an address to your site. Localhost is an address that means, literally, me. In numbers, it's 127.0.0.1, and that whole range is reserved for what's called loopback, meaning don't go outside, turn around, and come straight back to me. It's like writing me in the recipient field of an envelope. It never reaches the post office. It loops back into your own hand. So when you say localhost, it points at your computer. When your friend says localhost, it points at theirs. You didn't send them your site. You send them a mirror. So how do you point at one specific machine out of all the machines on Earth? For things working together. The IP address is the coordinate, a clump of digits like 142, 250, 66, 78. But asking a human to memorize that is insane, so we hang a signboard over it. The domain, google.com. Then DNS is the reception desk that takes the signboard name and looks up the real coordinate. And the port is the door number because one building has several entrances. Only 2 worth remembering. Door 80 is plain web traffic. Door 443 is the locked, encrypted kind. Coordinate plus door number. That's an exact spot on the internet. And there are 2 more gatekeepers standing between your laptop and the world. NAT is the operator in your router that translates all the devices in your house into one representative address, so the outside world sees only your front gate, never your laptop. And the firewall is the guard posted at that gate, whose default policy is roughly block first, ask never. So your friend can't see your site. That is not a bug. That is 3 separate systems doing their jobs correctly. Which means the fix isn't to fight them. It's to move your code onto a computer that already lives out on the public road. Always awake, fixed coordinate, door already open. That move has a name, and the name is deploy. Now, out on that public lot, 2 kinds of shop greet your guests. They both hang the same server sign, and they work completely differently. A web server is a vending machine. Can's already on the rack. Guest presses a button. The exact same can drops. Fast, simple, never wrong. Those cans are static files, HTML, images, CSS, a PDF. Already finished, handed over untouched. A web application server, is a barista. No cans on the menu. Somebody orders an oat milk latte, extra shot, half syrup, and it gets made fresh on the spot for that one person. That's your logged in page, your search results, your cart. And the reason you keep both is simple. Ask a vending machine for a latte, and it just sits there. Then the shop does well, and everyone shows up at once. In the late 90s, this had a name, and it terrified people. The C10K problem. Can a server survive 10,000 people connecting simultaneously? The engineer Dan Cagle coined it in 1999, And here's the part one love. His original example wasn't the web at all. It was a file distribution setup, an FTP host firing files at 10,000 clients over a gigabit line. So the problem that defined the modern web was first noticed by a guy watching file downloads. He named it precisely, and naming it precisely is what let everyone else solve it. Why was it so hard? Because the standard approach was one dedicated worker per guest. Guest sits down, and a worker stands beside them through the entire meal, ordering, waiting, eating, paying, unable to do anything else. 10 guests, 10 workers. 10,000 guests, 10,000 workers. And every worker costs memory just to exist. Here's the absurd part. Most of those guests are doing nothing. They're waiting. So you've got 10,000 employees standing perfectly still, being paid, next to people who are chewing. Around the 10,000 mark, the server falls over. Apache, the most popular web server of the 90s, worked exactly this way. And this is where the man from our opening walks in. Igor Sysoev, a system administrator at the Russian portal Rambler, decided in the fall of 2001 to build something lighter and faster than Apache. Not as company work, alone after hours, on his own time. He put it into production in 2004 and open-sourced it that October. He flipped the whole idea. Stop assigning a worker per guest. Let a few sharp staff circle the entire floor and slot a task into every gap. One guest reads the menu. The staffer takes the next table's order, then brings water to the table after that. That's event-driven architecture, and it carries tens of thousands of connections on a tiny crew. The name, by the way, isn't a grand acronym. It's just Nginx, spelled strangely. A side project spelled strangely now runs a third of the web. And Sysoev's creation has a second job, which is the one you'll actually meet. It stands at the front door as the reception desk. Every request hits it first, and it decides, image or CSS. I'll serve that myself. Needs a response built for one specific person? I'll pass it to the barista in the back. That's a reverse proxy. Regular proxy stands on the guest side, running errands outward. Reverse proxy stands on the shop side, greets the guests, and shields the workers behind it. Your guest has no idea whether there's one server back there or 10. They only ever talk to the desk. And that desk can split the line across several servers and lock and unlock the padlock at the door. Hold that thought.
Right.
So how do we actually ship the code? Let me show you the dirt road first, because you need to feel the pain to appreciate the highway. Old days, you finished your code and opened a tool called FTP. Think of it as a file shuttle bus between your computer and the server. You drag the files over by hand, one at a time. And human hands drop things. You move 47 of 50 files and forget 3, and naturally those 3 are load-bearing, so the site goes white and dies. At 2 a.m, and you can't remember which ones you missed. But the real terror of manual deploy wasn't the mistakes. It was that you could not undo it. The instant you overwrite the old files, the version that worked perfectly yesterday evaporates. By the time you discover the new one is broken, yesterday is gone. Which is why developers of that era performed a small, tearful ritual before every deploy, copying the whole server folder into something named, and I want you to picture this file sitting on a real production machine, backup _2003 _final _really final, in all capitals. That folder name is the entire emotional history of deployment before automation. So we need 2 things. Somewhere to keep the versions, and a machine to move them. Versions first. Picture a video game. Right before the boss room, what do? You save. Because if the boss flattens you, you restart from the save point. Git is a save point system for code. When things are working, you drop a save. That's a commit, a photograph of every file at that exact instant. Drop enough saves, and you can jump to any photo, anytime. Yesterday at 3. Last Friday. And a branch is a side path off the main road, where you can experiment freely. Works out, you merge it back. Flops, you throw the whole path away, and the main road never knew. and Git exists because somebody got their tool confiscated. The Linux kernel team had been using a commercial tool called BitKeeper for free since 2002. In 2005, a developer tried to reverse engineer how it worked. That counted as a license violation and the free usage was pulled. Overnight, from a codebase hundreds of people pile onto daily. Linus Torvalds refused to imitate anyone's tool. First commit April 7th, 2005, Git's birthday. Within days, Git could manage its own source code with itself, and by week 2, merging worked. He was building the tool while running the very thing the tool had to manage, assembling the plane mid-flight. And the name is a joke at his own expense. In British slang, Git means an unpleasant person. Torvalds' explanation: I'm an egotistical bastard, so I name all my projects after myself. First Linux, now Git. Then, and this kills me, he drove this world-changing tool for about 3 or 4 months, handed the maintainer seat to Junio Himano in August 2005, and went back to the kernel. He built the standard the entire planet now runs on, then wandered off because he had other work to do. Okay, versions handled. Now moving them, where the single most shouted sentence in software waits for you. It worked on my machine. Code doesn't run alone. Around it there's an environment, which language version, which libraries at which versions, Windows or Linux. Your laptop's environment and the servers are subtly different, and one subtle difference is enough. You ship the cargo perfectly, but the ground at the destination is a slightly different shape, so it won't unpack. The solution is gloriously blunt. Don't just ship the cargo. Ship the ground underneath it too. That's a container, and the analogy is literal. That giant steel box that moves freight between ports. Why did it change the world? Because the spec is identical. Bananas or car parts. The box is the same size and shape, so any crane at any port lifts it the same way. Nobody cares what's inside. Software containers work exactly like that. Your code plus its entire environment gets packed into one standard box, and that box runs identically on your laptop on the server anywhere. 2 words. An image is the blueprint and snapshot, the finished recipe. A container is the actual running instance you spin up from it. One recipe, same dish on 100 plates. And Docker, the tool that made this normal in 2013, came out of a man deliberately wrecking a company that was doing fine. Solomon Hike's company, .cloud, had paying customers and a working business. He just couldn't shake the feeling it wasn't succeeding fast enough. He called it being a slowly boiling frog. Better every month, never escaping the pot. So he bet everything on an internal tool. He had to tell his engineers they were scrapping months of work, and he had to let some of them go. And Docker was the 6th attempt at this problem. Of 5 failures came first. Now, the launch itself was almost entirely accidental, and it's my favorite part. The debut was a lightning talk at PyCon in March 2013, supposedly a small side room, maybe 30 people. It got moved to the main stage in front of hundreds. Then somebody posted the unfinished site to Hacker News and trashed it as vaporware that wasn't even open source yet. And the Stung team, shoved purely by that insult, forced an open source release in 2 weeks. So the technology that reshaped modern deployment shipped early because strangers on the internet were rude about it. Also worth knowing, Docker didn't invent containers. The raw kernel features already existed. They were just so painful to use that only experts touched them. Docker's invention was the packing.
Right.
Cargo packed, ground packed. Time for the conveyor belt, and its name is CI/CD. For intimidating letters, 2 simple halves. CI, continuous integration, is automated checking. The instant you push a new save to GitHub, the belt starts on its own. Does this build cleanly? Do the tests pass? It's the inspection station that catches smashed cargo at the entrance instead of at the destination. CD, continuous deployment, is the stretch that automatically releases the inspected cargo onto the real server. Whole picture in one line. Edit code, Push, then automatic build, automatic test, automatic deploy. You only do the first step. Why is this a revolution? Go back to 2 in the morning. Humans drop things, forget things, botch the order. Machines repeat a fixed procedure exactly, every time, without missing a comma. The mistakes don't get reduced. They get structurally eliminated. And it's fast enough to deploy 10 times a day. Then, where do you set the cargo down? 2 paths. Left path, rent a bare machine and install the OS, security, web server, domain, certificate, all by hand. Total freedom, enormous effort, and beginners get lost 9 times out of 10. Right path, a managed platform like Versal or Railway. Connect your repository and you're done. They lay the conveyor belt for you. If you're vibe coding, take the right path, no question. But no free lunch. The trade is convenience against control and cost. You can't step outside the frame the platform built, and when traffic grows, they charge a toll. And please hear this one. A free tier is a practice field, not a place of business. Set a spending limit or alerts before launch. That's a basic safety device, not paranoia. Now the most important section in this entire chapter, and I need you awake for it. Rolling back. Let's be honest about what vibe coding is actually like. The AI will confidently bulldoze code that was working perfectly.
No malice.
You say, nudge the login button a bit to the left, and it reaches into the payments logic next door, and payments stop. This isn't you being bad at this. This is just the weather. So real skill isn't preventing the AI from wrecking things. It's rolling back fast when it does. Principle 1. Always hold your last working point. The moment the code runs fine, commit, not only when some grand task finishes, but constantly in small pieces. Save every 5 minutes, and a disaster costs you 5 minutes. Work 2 hours without saving, and a disaster costs you 2 hours whole. Principle 2. Run risky experiments on a side path. Don't touch main, cut a branch, and let the AI go wild over there. Works, you merge it. Flops, you delete the path, and your working version was never in danger for a second. Principle 3. Know the 2 ways back. Revert drops one more save on top that cancels the bad change. It doesn't erase history, it stamps pretend that never happened over it. Safe. Use it for anything already shared. Reset actually rewinds the clock to a past save point and can wipe what's in between. Powerful, rough, for your own local work only. When in doubt, revert. And the sentence to carry out of here: the one who can roll back is the one who gets bold. Your code is live. Nobody can find it. All you have to give people is a clump of digits, and nobody's memorizing that to come visit you. The whole internet hit this wall once. In the early 80s, the early internet kept every computer's name and address in one single file, and every machine copied that entire file to use it. Picture the entire country walking around with an identical hand-copied phone book, and every time one new computer appears, everybody recopies the whole thing. It worked while the network was tiny. It collapsed the second the internet grew, and nearly every technology in this chapter exists because of that collapse. So, buying a domain. What are you actually buying? Not land. You're buying the right to borrow a name, a lease, usually a year at a time. Which means if you forget to renew, someone else takes it. Thriving services losing their address overnight to a missed renewal is far more common than it should be. 2 bodies are involved, and people mix them up constantly. The registry is the head office running the official ledger for one tail end, the .com ledger, for instance, and there is exactly one of those in the world. The registrar is the sales counter that files your registration onto that ledger. The counter is where you swipe your card. And that split was deliberate, so no single company could own both the ledger and the sales. Then you plant signposts, DNS records, that say where to send people who arrive by your name. An A record connects a name to an IP coordinate. That's the basic one. A name hands a name off to another name, an alias. MX decides which post office your mail goes to. TXT is a free memo board, mostly used to prove you own the domain. NS points at whoever manages the signposts. In practice, you'll touch A and name, and knowing the rest exists is plenty. Oh, and those tail ends were drawn in October 1984. .gov, .edu, .com, .mil, .org plus .30. .net didn't even arrive until the following year. Buy a .com today, and you're tracing a line somebody drew 40 years ago. Now, the part that makes people lose their minds. You change the A record to point at the new server. Your friend still sees the old one. You definitely changed it. There are information desks all over the world, and each one holds on to answers it already looked up, a cache, so it can reply instantly instead of asking head office every time. The shelf life of that copy is the TTL. Set it to 1 hour, and desks worldwide will keep serving the old answer for up to an hour. That slow refresh across the planet is DNS propagation, and it is not a bug. Paul Makapetris designed it that way in 1983, deliberately scattering the answers instead of centralizing them. The delay that annoys you today is a 40-year-old design decision that's the only reason the internet could scale at all. One field trick, because this one's genuinely useful. Planning to move servers? Lower the TTL the day before to something short, like 5 minutes. Then the old copies expire fast, and when you make the real change, it takes effect almost instantly. Once everything's settled, raise it back up. That's how professionals move house with no downtime. And the most common beginner scream, "I deployed and the site won't show," is half the time not a failure at all. It's propagation that hasn't finished. Before you tear up your code, check from a different network, like your phone's data. Different answers on the two? The culprit isn't your code. Next, the conversation between your guest and your server is currently a postcard. Everyone it passes through can read the whole thing. Passwords, card numbers, wide open. Security people warned about this politely for years, and nobody listens to a polite warning. What flipped the industry was one developer being obnoxious about it. October 2010, Eric Butler released a Firefox extension called Firesheep. On shared cafe Wi-Fi, it grabbed the unencrypted session cookies floating around and let you log into the account of the person sitting next to you. With one click. No expertise required. 100,000 downloads in 24 hours. And the response is my favorite piece of activism in security history. The Electronic Frontier Foundation published a piece about it titled "Bad Ad Websites," spelling bad with a sheep's bleat because of the flock of sheep pun, telling everyone to turn on encryption site-wide immediately. It worked. Facebook and Twitter started switching HTTPS on by default. The fix itself is swapping the postcard for a sealed envelope. TLS is the technology that seals it, and HTTP wrapped in TLS is HTTPS. It does two jobs at once. Encryption, so nobody in the middle can read it, and proof of identity, a certificate where a trusted authority vouches that this server really is who it claims. That padlock by the address bar is the seal. But certificates used to be expensive and annoying to get, so small sites just went without. What broke? That was Let's Encrypt, a non-profit certificate authority that started issuing certificates free and automatically in 2015. Josh A.S. conceived it at Mozilla with a colleague. At almost the same moment, the EFF and a University of Michigan team were independently dreaming the identical dream. In 2013, the groups found each other and merged into one nonprofit. And notice the shape of this. A group of people sitting exactly where they could have made a great deal of money, deliberately choosing the option that doesn't. A nonprofit responsible for the padlock on half the web, running on donations. That precariousness is permanent, and they took it anyway. Free wasn't enough, though. It also had to be effortless, and that took Peter Eckersley, the EFF's chief technologist, who led early development of CertBot and automated the tedious labor of issuing and installing certificates. He'd started that research after meeting Michigan's Alex Halderman at a conference in 2012. Halderman's other job, incidentally, is securing voting machines, Sealing the web's communications and protecting elections turn out to be the same fight for trustworthy systems. Eckersley died in 2022. And how colleagues remember him is this: showing up to board meetings with a messenger bag over his shoulder, helmet hair from his bike, cheeks pink from pedaling. The man holding up the security of half the internet commuted by bicycle. One caution and one happy ending. Certificates expire. Let's Encrypt's last 90 days, so auto-renewal is the whole game. The short life isn't a flaw, it's pressure. Automate it or you won't survive. And the happy ending. When this movement started, roughly 30% of web page loads were encrypted. By 2023, it passed 80, and over 95 in places. So the EFF shut down its own once essential HTTPS extension, because every major browser now defaults to HTTPS on its own. A tool that succeeded so completely it made itself unemployed. You almost never get to see that. Now the good problem. You get featured somewhere, and everyone arrives at once, and one server has a ceiling. The line grows, responses crawl, and it dies at the exact moment it's doing best. This dread had a name too. In the late 90s, as pages got heavier and everyone waited forever, people started mocking the World Wide Web by calling it the World Wide Wait. 3 weapons fix this. A load balancer is the greeter at the bank entrance, spreading arrivals across open windows, so no machine gets buried. Auto-scaling watches the line and opens more windows automatically when it's crowded, then closes them when it thins, so you pay for exactly what you used. And the third is the CDN, a content delivery network, which lays copies of your heavy static files all over the world in advance, so guests grab them from whatever's nearest. Seoul gets Seoul. New York gets New York. Your main server gets much lighter, and everyone gets faster. 2 traps, though. First, more servers means more cost. Malicious traffic comes straight back as a bill, so always set a cap. Second, and this is the one that gets people, you can multiply servers all day, but if the database behind them is a single machine, the jam just relocates. 10 new windows, 1 vault in the back. The line simply reforms in front of the vault. Bottlenecks always find the weakest link. And the CDN exists because of a mathematician. In the late 90s, the web's creator Tim Berners-Lee was worried about that coming congestion and put the problem to his colleagues. Tom Layton, an applied math professor across the hall, took it up, and his grad student Danny Lewin solved it, with algorithms, working out how to scatter and replicate content close to the user. One core invention is called consistent hashing, and it came out of a math lab at MIT. The traffic problem was solved not with better cable, but with better math. Lewin co-founded Akamai in 1998. He was aboard American Airlines Flight 11 on September 11, 2001, and is believed to have been killed resisting the hijackers. He was 31. The speed of the modern web rides on a road he never got to see finished. One more thing before we move on, and it's where beginners and professionals visibly separate. The beginner deploys, dusts off their hands, and leaves. The professional knows deploy is the beginning. From that moment, the server lives on its own. So, how do you know it's all right? Not by waiting for a user to tell you the site is dead. 3 instruments. Logging is the black box, a record of every action, moment by moment, that you crack open after an accident. Monitoring is the dashboard, load and response times in real time, so you see the engine overheating before it seizes. Error tracking is the automatic accident report. The instant code blows up. It tells you where, what, and to whom. The shared goal is one thing: knowing about a failure before your users do. So, where are we standing? You started this lecture with code trapped in a locked room, visible only to you, pointing at a mirror. Now it lives on a machine that never sleeps. It wears a name a human can type. Its conversations travel in a sealed envelope instead of on a postcard. It splits its guests across several servers, keeps copies of itself near every major city on Earth, and tells you it's in trouble before your users do. the road out into the world is built. You built it. Let's tie it together in one pass. 3 gates. Gate 1. A server is just a computer that stays awake, and you find it by coordinate, signboard, reception desk, and door number, IP, domain, DNS, port. Your local host is a mirror pointing at yourself, and NAT and the firewall are doing their jobs correctly when your friend can't see it. That's why deploy exists. Out front stands the event-driven reception desk that carries 10,000 guests on a tiny crew. Gate 2. Shipping. Git holds your save points, Docker ships the ground along with the cargo, and CI/CD replaces the human who drops 3 files at 2 in the morning. And the most valuable skill on that gate isn't building, it's rolling back. Commit densely, experiment on side paths, and remember that the one who can roll back is the one who gets bold. Gate 3. Wearing an address and surviving the crowd. A domain is a lease, not a purchase. DNS caches on purpose, which is why propagation makes you wait. A 40-year-old design decision, not a bug. HTTPS swaps the postcard for a sealed envelope, and it's free now because some people chose the option with no revenue model. And when the crowd arrives, a greeter splits the line. Windows open and close automatically, and warehouses near every city serve the heavy files. Now notice what every tool on this road has in common. Nginx was a hobby written after work by a man later raided over it. Git was built in 2 weeks by someone whose tool got confiscated. Docker came from a founder who tore apart a company that wasn't even failing on the 6th attempt and shipped early because strangers mocked him online. The CDN came from a mathematician who never saw it finished. Not one of these was handed down by a committee having a comfortable afternoon. Every road you walk today was paved by somebody cornered, who named the problem precisely and refused to let go. Everything in this lecture comes from Region 4 of a book called the AI Development Atlas. It's built on one idea. In the age of AI, the person who commands the tool isn't the one who memorized the most syntax, it's the one who knows the terrain, who can point at the map and say precisely, the problem is right here. 10 regions from the front end all the way to AI transformation, each drawn as terrain you can actually walk. If today's road made sense to you, the full atlas is available now, and the link is in the description below. But your service isn't finished. 2 things are still missing, and both of them are the kind that end companies. You still have to take money, log people in, and send mail, none of which you should build yourself. And your front door is currently wide open. So next time we close both external services and the locks you set before you ship. Subscribe, and I'll see you on the next trail. DK Corporation know the terrain. Command the tools.